To prove the cosine rule, I'm going to start by drawing a sketch of a triangle, which I'm going to label A, B, C. Means this length is A, this length is B, and I'm going to drop down that perpendicular height, call that H, and I'm going to call this length here X, which means that this length here is going to be C minus X. And let's call that point there D, just so we can refer to it if we need to. So first of all, I'm going to look at doing some Pythagoras. I'm going to do Pythagoras in triangle BCD. That's this triangle over here. Now from that, I have that A squared is equal to H squared plus C minus X all squared. So A squared is equal to H squared plus C squared minus 2CX plus X squared. And I'm going to call that equation 1. Now I'm going to do a very similar thing, but in the other triangle, I'm going to do Pythagoras in triangle ADC. And I'm going to get B squared is equal to H squared plus X squared. And I'm going to rearrange that slightly to give me H squared is equal to B squared minus X squared. And I'm going to call that one equation 2. And now what I'm going to do is I'm going to substitute number 2 into number 1. And when I do that, I'm going to get A squared is equal to H squared is equal to B squared minus X squared plus C squared minus 2CX plus X squared, which simplifies down to these X squareds cancel out. So I get B squared plus C squared minus 2CX. But now I'm going to work out what X is. X in triangle ADC. We can see that cos of this angle is equal to X over B, which means that X is equal to B cos A. And if I call this one 3 and this one 4, I'm now going to sub 4 into 3. And I get A squared is equal to B squared plus C squared minus 2 BC cos A, giving me the cosine rule with A as the length that is unknown. We do need to be a little bit careful, like we were with the area formula. What happens if we were dealing with an obtuse angle? It falls out in much the same way. The only difference is in here we get cos of 180 minus A, but that gets dealt with in a very similar way to how it did previously in the area formula. Do have a look at it. We haven't looked at that result yet. We will do it in periodicity and the unit circle. So if you want to wait till you see that and then come back and have a go at this, that would be an excellent way to practice this skill.